Okay, so the second concept for this week is ratio strength. So if you're following along in the book, ratio strength starts on page 341. So I want us to shift gears a little bit. When we were talking about percentage strength, we always are talking about X over 100. Now, ratio strength, new concept here. Ratio strength is always 1 to X, which a ratio is just another way to write a fraction, just a fraction on its side. So 1 to X or 1 over X. Now, just like percentage strength, our numerator is always our active ingredient. Our denominator is always our total volume or weight. So in this case, our 1 is our active ingredient and our X is our total, okay? So different than percentage strength. So you got to keep these two concepts separate from each other. We're going to talk about how to convert from ratio strength into percentage strength and back the other way here in just a little bit. But ratio strength and percentage strength, active always on top, total always on bottom. And just like percentage strength, we're always using the units of grams for our weight measurements and milliliters for our volume. We can also have the 3 different types of medications as well. So a weight per volume, a weight per weight, or a volume per volume. And we're going to take a look at some examples here as well. Okay, so number 11 on the worksheet, it says interpret the following. We have a 1 to 2,000 sodium bicarbonate solution. So we're just writing out the interpretation. What does this mean? Well, remember ratio strength, our 1 is always our active ingredient. So here, they don't specify weight per volume, weight per weight, or volume per volume. So remember, we always assume weight per volume unless they tell us otherwise. So in this case, we would have 1 gram of sodium bicarbonate per 2,000 mils of total solution. So that's just me rewriting this ratio in words here. And that's what you're going to want to do for practice problem C in your book. So practice problem C says interpret the meaning of the medication. So on these lines, that is how I want you to interpret, okay? So now let's look at number 12. How many grams of sodium bicarbonate are in 400 mils of a 1 to 2,000 sodium bicarb solution? Well, let's start with what we know. We know that we have a 1 to 2,000. We can write that as a fraction. 1 gram of sodium bicarb in 2,000 mils of solution. So it's saying how many grams of sodium bicarbonate are in 400 mils. So we can use ratio and proportion just like we did with percentage strength. Set that equal to what we're looking for. We're looking for grams on top. Milliliters goes down on bottom. So we're going to take 1 times 400, which is just 400, and we're going to divide that by 2,000. And I get 0.2. So we need 0.2 grams of sodium bicarb. Now it says, what is the strength in milligrams per milliliter? Well, I can either use what we just solved the 0.2 grams out of 400 or the 1 gram out of 2,000. It really doesn't matter. I'm just going to pick this one because that's what we just solved for. So I know that there's 0.2 grams in every 400 mils. Now they're wanting to know how many milligrams there are per mil. So I need to convert my grams into milligrams. So grams to milligram, we're going to take that times 1,000, or just move your decimal 3 places to the right. So 1, 2, 3. That's the same thing as 200 milligrams in every 400 mils. And now I just want to reduce that because they want milligrams per mil. So we're really just dividing this. If it helps, you can set this equal to x over 1. But essentially, we're just taking 200 divided by 400. So 200 divided by 400 gives us 0.5 milligrams. So my strength in milligrams per mil would be 0.5 milligrams per every 1 milliliter there. Okay, so now moving on to 13. A physician orders 80 mils of a 1 to 500 sodium hypochlorite solution to be used in the office. How many grams of sodium hypochlorite are needed to prepare the solution? All right, well, we know that we have a 1 to 500, so let's start with that. We know that that's going to be 1 gram of sodium hypochlorite in every 500 mils of solution. And we know that we are preparing 80 mils, and we're looking for how many grams of sodium hypochlorite. So how many grams? Our X is going to go on top. We're needing to make 80 mils. So essentially, we're taking 80 divided by 500. X is 0.16 grams. Now it says, how many mils of solvent are needed? Well, let's think about what's happening here. We are taking 0.16 grams of this sodium hypochlorite, so that's going to be in a powder, and we're making a total of 80 mils of solution. So remember, if you ever have a weight per volume, like we do here, I cannot tell how much volume this powder will take up when it dissolves, because we're going to put that in a container. So they're going to have your 0.16 grams, and I need to add enough solvent in here to get up to my total of 80 mils. But I cannot just subtract grams from mils, because grams is a unit of weight, milliliters is a unit of volume, okay? So we cannot determine this amount of solvent. So in those situations, we always use QS, so quantity sufficient. So we're going to say QS with solvent to 80 mils. That means we're going to add enough solvent to get us up to that final volume of 80 mils. If you're still struggling with that concept, let me know, and I'd be more than happy to show you a real life example of that as well. The whole idea is that this powder takes up space when it dissolves, and we're not going to know how much space exactly that is. All right, let's go on to 14. How many mils of epinephrine 1 to 1,000 are needed to provide a 0.5 milligram IM dose? Now, this is very important. Remember our units here. We have 1 to 1,000 We're assuming that this is a weight per volume, but remember a unit of weight is always grams. So 1 gram of epinephrine in every 1,000 mils of solution. Now they're saying how many mils, so I know that my X is going to go on the bottom. I needed to provide a 0.5 milligram dose. Well, this is in grams. So I need to either switch this to milligrams or convert this into grams. Either way, I'm just going to go ahead and convert this one. So 0.5 milligrams, we're going to go to grams. So we're going to the left, or we're dividing by 1,000. So 1, 2, 3, 0.0005 grams. All right, so now I can solve for X. So 0.0005 times 1,000 gives me 0.5, and if I divided that by 1, it's still just going to be 0.5. 0.5 milliliters. So a very tiny amount of solution to give us a very tiny amount of medication. So always double check your units on there. Just remember, when we're talking about ratio strength or percentage strength, unit of weight is always grams. Unit of volume is always milliliters. Okay, number 15. What ratio strength solution is made by dissolving Benadryl 50 milligrams in a lotion to make 150 mils total here? Okay, so this time we're looking for the ratio strength. Okay, so let's start with what we know. We know that there's 150 milligrams, or sorry, 50 milligrams of Benadryl in the 150 mils total lotion here. Now, we're looking for ratio strengths. Remember, back to the front here, ratio strength is always 1 to X or 1 over X. So I can set what I know equal to 1 over X, and that's going to give me the second part of my ratio when I solve here. But just like the last problem, do not forget that the units of ratio strength and percentage strength, the unit of weight is always gram. So this is actually 1 gram, and mils would be down here. Now mils are fine, but here I have milligrams, here I have grams. So I need to convert this into milligrams or convert this into grams. I'm going to convert this one into grams because I want to keep my ratio as a 1 to X. Okay, so milligrams into grams, we're going to go 3 places to the left. So here we have 0.05 grams. Now I can solve. So I'm taking 150 times 1, which is just 150, divided by 0.05. And that gives me 3,000. Now the question wants our answer in ratio strength. So 1 over 3,000 is the same thing as 1 to 3,000. So that should be your final answer. If they're asking for ratio strength, leave your answer in a ratio form. Okay. These are the types of questions that get missed the most frequently, and it's just because people forget that we're always working with grams and mils. So we have to do that conversion first. Okay. Now, we're going to now go from a ratio into a percent. So if you can remember your rules here, percentage strength is always X over 100. Ratio strength is always 1 over X. If you can remember those two concepts, you should be good when you're converting between the two. So number 16, what is the percentage strength of a 1 to 12,000 weight per volume solution? Start with what we know. We know that we have 1 gram in every 12,000 mils, and we're looking for the percentage strength. Well, I just said percentage strength is always X over 100. So we can set up our ratio equal to X over 100. Our X will be our percentage strength. So cross multiply, we have 100, and we're going to divide that by 12,000. That gives me a very small number, 0.0083. Now, that number is my percentage, okay? Another common mistake is when people see a decimal here, they want to change that into a percent. You do not have to do that because that X in percentage strength, that X is your percent. So all you have to do is just add a percentage sign on the end of that there, okay? Now, number 17, what is the percentage strength of a 1 to 500 weight per weight ointment? So this is the first weight per weight that we've seen so far. All that means is we just use gram per gram. So we have 1 gram over 500 grams. Still asking for percentage strength. So percentage strength, once again, always X over 100. So just set that equal to X over 100. Your X will be your answer. Just put a percentage sign on the end of that. So go ahead and solve for that one on your own. And then these last three here are going the other way. So going from percentage strength to ratio strength. So 18. What is the ratio strength of a 0.05% weight to volume solution? Okay, so let's go back. Percentage strength. Anytime we see that percent sign, we can just take this number and put it over 100. So we know that there's 0.05 grams in every 100 mils of solution. Now this time we're looking for ratio strength. Remember, ratio strength is always 1 to X or 1 over X. So I can just set this equal to 1 over X. The X will give me the second part of my ratio. So when I solve here, we have 100 divided by 0.05, which gives me 2,000. So X is 2,000. Remember, they want the final answer in ratio form. That's the second part of my ratio. So it is 1 to 2,000. All right, so go ahead and do number 19 and 20 on your own. You should be able to do those based on the one that we just did here. Okay, I wanted to go through one last example. I am on page 344 on number 8. So this question says, how many grams of active ingredient are in 400 grams of a 1 to 2,500 weight per weight ointment? So here's another example of a weight per weight. So first, let's start with what we know. We know our ratio strength. we know that we're gonna have 1 gram of active ingredient in 2,500 grams, because this is weight per weight, of total ointment. Now the question is asking, how many grams of active ingredient are in 400 grams of an ointment? So these weight per weight, same with volume per volume, are a little bit more tricky because your units are the same. So you really have to read the problem to know where your X is going to go on this side. Now, read the question. How many grams of active ingredient? Well, our active ingredient is on top. So that's where our X is going to go. That's what we do not know. Are in 400 grams of an ointment. Well, our grams of total ointment are on the bottom. So that's where our 400 grams must go. So especially on your worksheet this week, really make sure that you're reading the questions carefully, especially when it comes to the weight per weight or the volume per volume calculations there. And then for this one, you should be able to solve for X on your own. I just wanted to make sure that you knew how to get that set up.